In this video, we'll show you how to use Gremlin's Services Discovery feature. Services Discovery automatically detects services running in your environment and lets you target them when running chaos experiments. This makes it easy to uncover the various services running in your environment, run chaos experiments on distributed applications, and also track your progress towards improving the reliability of each service. To demo this feature, we'll be using an open source e-commerce application called Online Boutique running on Kubernetes. To get started with Services Discovery, you'll first need to deploy version 2.16.4 of the Gremlin agent or higher. You'll also need to enable the process collection flag, which allows the Gremlin agent to detect the services running on your hosts. This is enabled by default for new users. Existing users can visit our documentation site at gremlin.com/docs to learn more. In the Gremlin web app, I'll click on the All New Services button. Here, I can see a full list of my discovered services by name. This list includes our Kubernetes deployments, as well as processes running directly on my hosts. I can see details about each service, including the number of active targets that the service is running on, the Kubernetes cluster and namespace that it's running in, container and image details, the port number that it's listening on, and the service account that it's running as. If I see a service that my team manages, or that I want to test frequently, I can click the star icon to star it. This moves the service to the top of the list so that I can find it more easily. I can also ignore a service so that it doesn't appear on the list. This is useful for hiding services that aren't relevant to me or my team, that aren't ready for reliability testing, or that don't require reliability testing. For example, I'll ignore the Gremlin agent so that I don't accidentally run experiments on it. I can also use the search box to search for a specific service by name or by configuration detail such as port number. Lastly, I can sort this list by name, starred services, or by the number of active targets. Let's take a closer look at one of the services. Here is the recommendation service. As customers browse our e-commerce shop, the recommendation service displays recommended products to them. I'll switch over to the e-commerce website so we can see what this looks like. When I click into a product, you can see the recommendation section at the bottom of the page. This data is retrieved from the recommendation service by the front end. We'll come back to this later in the demo. Back in the Gremlin web app, I'll click on the service to open the service details page. Here, I can see when the service was last updated, add a description explaining what the service does, view the configuration details automatically detected by Gremlin, link to dashboards, my monitoring tool, link to my incident management runbooks, and assign an owner. This lets me track everything I need to know about the service within Gremlin, including what it does, where to look if something goes wrong, and who's responsible for it. In the activity feed, I can see a full history of attacks ran on this service. This way, I know when the service was last attacked, what type of attack was performed, and I can easily view the results of the attack or rerun the attack. I can also see the number of attacks ran month over month so that I can track the frequency and regularity of my chaos experiments on this service. Lastly, by clicking the Targets tab, I can see the systems that this service is running on. Since this is a Kubernetes application, this shows the deployment name and the cluster that it's running in. If this was a process running directly on my hosts, this would show each host that the process was discovered on. This makes it easy to test distributed applications since Gremlin automatically knows which targets to distribute the attack to. I don't have to select each host myself, use complex tagging rules, or spend time mapping my services to my hosts. Now, let's run an attack. For this attack, I want to see what happens when the recommendation service becomes unavailable. The recommendation service is a direct dependency of my website's front end, but in theory, it shouldn't be a critical dependency. In other words, my website should keep working even if recommendations are unavailable. First, I'll go back to the Details tab, then click Attack Service. This opens the attack screen. The recommendation service is already selected, but note that I can easily select another starred service or use the drop-down list to select another service. Next, I can view the blast radius, which is the set of systems impacted by this attack. I only have one pod running in this deployment, so this looks good to me. Now, I'll select a black hole attack. This will drop all traffic to the pods running in the deployment. I can limit my blast radius further by retrieving the port number from the service details page and entering it in the local ports field. Now, let's run the attack and check our website. Uh-oh, looks like the website is unresponsive. Let me go back to the Gremlin web app and stop the attack. Once I click the halt button, Gremlin immediately stops the attack and reverts the impact. I'll add my observations here so that we have a record of the outcome. Now, if I go back to the service details page, I can see the attack listed in the attack history. I can click into the attack details to see the results of the attack, including the notes I took. This way, I can easily track the reliability testing that I've done on this service. I can also use this information to identify gaps or risks and prioritize future attacks. With Services Discovery, Gremlin makes it easy to proactively improve the reliability of your services in a simple, safe, and secure way. To get started today, visit gremlin.com/getstarted.